Hello everyone, my name is Purnachandarwa, bearing rule number 17951802449. Today my topic is about operation issues for FACT devices and operating planning perspective. Issues related to FACTS. FACTS means flexible alternating current transmission systems. For the effectiveness of the controllers, the selection of location and feedback signal of FACTS based stabilizer should be determined. On the other hand, the robustness of the controllers to the variation of power system operating conditions is equally important factor to the undertaking. Also, the coordination among different power system stabilizers is an issue to avoid the side effects. Additionally, performance comparison is an important factor that helps in selection of specific FACT devices. Reactive power compensation needs required by the system by FACTS to be investigated. FACTS has wide influence on the system compensation, so effective and proper selection is to be done. Reactive power compensation by FACTS for power transmission line led to enhancement of transmission capacity, providing permissible line loading and influencing to work within the boundary conditions. To keep the voltage profile along the transmission line within acceptable limits, this leads to optimization of line insulation cost factor. Controlled compensator, reactive power compensators, are also used to improve system stability depending on their characteristic. They enhance the system response, such as steady state, dynamic, or transient. These are used for power oscillation damping control of the system, which enhance the system stability. Controller design issues for FACT devices. In modern deregulated power system, FACT devices providing following assistance for enhancement of power system stability. Balanced power flow. Balanced power flow control over wide range of operation conditions, including contagious of power system. This lead to utilization of power system efficiently. Balancing power flow in parallel networks operating at different voltages. Diminishing in inter-area power oscillations. Subtraction of synchronous resonance (SSR). Avoiding to construction of new transmission facilities by enhancing of power capabilities of existing coordinators of power systems. Controllers for DFACTS devices are designed on basis of intelligent adaptive digital controllers based technique with response capable for wide area. Controllers should not be designed for high level of damping as it is not supportive way of designing for wide area system control. Controllers should be designed with interconnection in system should be within reliable operation region and working within security limits of power system. These are the FACT devices and its impacts. As we can see, first it is termed to be the issue and what is the problem that causes in the transmission line and correction action and FACTS controllers which are used to control the issue. Let's talk about voltage limit. Voltage limit issue arises to have four problems. First one is low voltage at heavy load, which is the correction action is supply reactive power, reduce line reactance. This can be done through SVC, STATCOM, TCSC, DSTACCOM. High voltage at low load observes reactive power. Correction action is the devices which are used to control this issue is SVC, STATCOM, DSTATCOM. And another problem is high voltage flowing on outage. Observes reactive power, prevent overloads. The devices which are used to control this is SVC, STATCOM and DSTATCOM. And final voltage limit issue problem is low voltage flowing outage. The correction method is supply reactive power, prevent overloads. This can be done by using SVC and STATCOM. And another issue is terminal limits. Transmission line loading. Increasing the correction action is increasing transmission capacity. This can be done using TCSC, SSSC, UPFC, IPFC, DPFC. The another issue is short circuit power. Problem is high short circuit current. The correction action is limitation of short circuit current. This can be done using the same devices which we used for the terminal limits. The fourth issue is about load flow. The problem arises due to load flow is power distribution on parallel lines and load flow reversal. There are two correction methods which can be done using similar correction FAC devices, which is adjust line reactance and adjust phase angle. The last issue regarding the FAC devices is stability. The problem is limited transmission power. The correction action is decrease line reactance. This can be done using TCSC, SSSC, DSSC and UPFC. Let's talk into the various methods of compensation and FAC devices which we use right now. Compensation methods are of two types: shunt compensation and series compensation, which we will be talking to in detail in right now. FAC devices are divided into 8 types, which are first one as continues to static VAR compensator, which is called SVC, Thyristor controlled series capacitor TCSC, Thyristor controlled phase shifters TCPS, static synchronous compensators SSC or STATCOM, static synchronous series compensator SSSC, unified power flow controller UPFC, distributed static series compensator DSSC, distributed power flow controller DPFC. Shunt compensation. Shunt compensation are used to enhance, improve power transfer capability and for reactive voltage drop compensation in the line, which is either in the distribution or transmission system. Shunt compensation is employed mainly at the midpoint named midpoint compensation or at the end of the transmission line to improve the voltage profile and providing power quality improvement for the line power. As we can see, shunt compensation circuit as shown in the beginning. Talking to series compensation. Series compensation of power lines are done to increase the maximum power transmission capacity of the lines. By series compensation, net line voltage drop would become less subsequent onto line loading condition of power system. Since compensation reduces the line reactance of power transmission line by introducing the series compensator while neutralizing the counter reactance effect in existing system. Synchronous voltage source in series with the line is shown in the figure. Let's talk about FAC devices. Static VAR compensators or SVC. SVC are shunt compensator FAC devices for the power flow control in the system. They consist of fixed or switched capacitor banks or reactors or combination of both depending on the requirement of the system. These compensators draw leading or lagging reactive power from the lines. Thus, they regulate voltage, improve system dynamically and steady state stability. They are also termed as static VAR switches as they are employed switching concept of control of VAR. SVC topologies and step-by-step procedure is shown in the figure. Thyristor controlled series capacitors, which are TCSCs. Due to the development in modern power electronics devices such as GTO, IGBTs, IGCTs, MTO, and power transmission, with improving rating of thyristors also. These led to the effective operation of switching control technology due to the improvement of switching technologies. Capacitance in series banks of TCSC can be controlled smoothly and in step-wise they lead to the following modes of operation of TCSC are mentioned below. The first one is bypassed thyristor mode, blocked thyristor mode, partially conducting thyristor mode or capacitive veneer, partially conducting thyristor mode or inductive vernier. The major difference between the capacitor vernier and inductor vernier or combination of both can be shown in this figure. Thyristor controlled phase shifters (TCPS). TCPS has the ability to produce a phase shift between phases of terminal voltage which are independent of throughput current. If we neglect the losses of the system and device action, then TCPS does not consume our productive active and reactive powers. TCPS are mainly employed as thyristor controlled phase shifting transformer, which we also known as phase angle regulation transformer (TCPAR), producing phase shift in the voltage phases of the system for controlling of the active power flow in the system. Static synchronous compensators (TSSC or STATCOMs). STATCOM is a shunt compensator connected in shunt to the line, thus introducing current vector control of the system. Static COM are of two types: voltage source STATCOM, current source STATCOM. In the former, capacitors are used as energy storing components of the system, thus it acts as a voltage source due to the storage of potential charge, whereas in later inductor or reactors are used for reactive energy storage, which is mainly current modulation system, thus termed as current source. As you can see the difference between the capacitive and inductive through the graph, which is voltage versus current. Static synchronous series compensators (SSSC). SSSC is series connected device used a coupling transformer in series by which it can be able to control voltage of the line and modifies line impedance. Due to the power electronics controllers, has been ability to produce phase shifting in relation to the line current. SSSC has the ability to exchange both real and reactive power in transmission system. If the injected voltage is in the phase with the line current, then real power will be regulated. On the other hand, if the injection of the voltage is in correlated to line current, then reactive power will be regulated. This depends on the absorption or reaction. Unified Power Flow Controller (UPFC). UPFC is a combined power flow controlling device which has both series and shunt component. Due to this behavior, UPFC is able to control line impedance, line voltage, and power angle, all three parameters of the power system, which are essential to route the flow of power in the system networks. Due to the wide range of controllability, these devices are having dynamic behavior over transmission system parameters. UPFC is capable of controlling directional flow of power system. It enhances the power transfer capability of transmission line to be within the terminal loading limits of the transmission system. Distributed Static Series Compensator (DSSC). DSSC is a new generation DFACTS device derived from the parent SSSC or S3C controller. DSSC is distributed device rather than to be placed centrally located at one place in the system. Due to these distribution components along the transmission line, it is having better control capability in terms of system response improvement rather controlling at central component control. In DSSC, single turn transformer is used as series element to distribute the static device which is placed at optimal location along the line. Distributed Power Flow Controller (DPFC). DPFC is derived from the UPFC carrying all its inherent characteristics. Only difference is that despite of fixed capacitor in UPFC and DFFC provides distributed capacitor and central controlled capability. Due to this characteristic behavior, it has the ability to control the transmission line voltage, impedance and angle. DPFC's advantages over UPFC as it is required series converter of small power rating which may be also a single phase. Induction level due to voltage is less than 3-phase converter in single phase controller which increase reliability and reduce cost. DPFC is also from the family of combined power flow controller of FACTS having wide range of control capability which has shunt controller and series controller, whereas series controller is distributed along the line and shunt controller is located at the end of the transmission line. It acts as an active high pass filter to eliminate harmonics. Conclusion. FACT devices provide wide range of control of power system parameters to the flow of power in transmission and distribution systems of modern systems. In fact, controller implementation of different compensation typologies lead to different development of different controller. Modern trend is to for combined controllers as they derive better properties and characteristics from their parent controllers. Thank you.